Okay, so I got some ethyl citrate and I baked copper powder into it, but you're not supposed to do that because it destroys the ethyl citrate. It can't take the heat, so it ended up being brittle and weak. But I could still demonstrate something. See how this one's actually grey? That's because it's been put into a solution of aluminium sulphate, and it's actually transmuted from copper metal colour, which is like this. It ends up being a bit dark, but that's sort of like pinkish, to this grey colour. Look at that, and that's aluminium. And I didn't put it in any metal. I actually just put it in the aluminium sulphate, and it's actually transmuted to a grey colour. There, that's definitely more grey than this one. Let's see how that one has got a grey. It's not that obvious. It's a bit of a. It's only a like slight sort of thing. I dipped it a few times, but it only seems to happen very slowly. It changing colour. I thought it was going to be really quick, like putting a bicarb brick inside a copper sulphate. That instantly changes. But it's a lot slower than that. But you can see it just comes out of the alum. But when it goes into the polymer, it transmutes from compound to metal color when it's in presence. When it joins the polymer matrix. What do you want to go on there? It actually turns metal colored, and that's why you can actually have red copper sulphate, and that's actually copper sulphate in the color of the metal. Like this is red, that's actually copper citrate, but copper citrate is usually blue, but here look, that's red copper citrate. Yeah, that's red copper citrate. But look at that, now that's grey copper citrate because it's aluminium citrate. That's actually grey aluminium citrate. But it's only subtle. And you're not supposed to bake copper powder into ethyl citrate, you're supposed to use glycerin citrate.